Hey, data analysis. Start off today with a joke. I broke my finger last week on my left hand, but on the other hand, I'm okay. So it'll make your Tuesday, that's for sure. All right, today's arithmetic are arithmetic sequences, and we're going to talk about writing the general equations for them. So that's how we will get started today, arithmetic sequences. Kind of a funny, weird thought. This word, we say arithmetic when it's an adjective, so it's an arithmetic sequence. We say arithmetic when it's a noun. So like, oh, we're going to do some arithmetic. Then we say arithmetic. But when you use it as an adjective, you say it differently. Kind of a goofy word. Not sure why we do that in our English language, but we do. So let's get started. We've done a couple of these, but we're going to take them a step further. So if I said number 1, 3, 5, 7, 9, I said, what are the next three terms? You would tell me 11, 13, 15, because you know the rules, just add 2. All right, you know the rules, add 2. So we're going to come up with now is an equation that's going to represent this sequence. All right, so the question may say something like, what is the equation for this sequence? All right, so what is the equation for this sequence? So here's how you do this. What you do is you talk about these terms. So like this is the first term, 3. This is the second term, 5. This is the third term, 7. So we each have these terms. We're going to number them. So I'm going to put up here, I'm going to scribble out this 1 because that may be confusing. That was the problem number. This is the first term. This is the second term. Third term is 7. Fourth is 9. The fifth is 11. Sixth is 13. The seventh term is 15. All right. So what is the equation for this sequence? All right. So here's how you do this. You use the old school y equals mx plus b. Okay, old school equation for a line. Let's review. This m means slope or the rate of change, how much it's changing. B is the y-intercept. That's when x is 0. Okay, so slope is how much it's changing, and b is the y-intercept or when x is 0. Okay, so let's assign this top row is going to be my x's. This bottom row is going to be my y's. Write it in there. Okay, so the first thing to think about is how much is each one of these numbers changing? Right? How was it changed by? Right, that's the change. The rate of the change is the slope, how much it's going up or down by. So all you do is write 2x. Okay, 2 goes in there, 2x. Okay, so y equals 2x plus b. Now we have to find b. B is the y-intercept, or when x is 0. I'll write that down. When x equals 0, that would be the y-intercept. So I drew a little picture over here. Wherever this line crosses this point, this value is going to be 0. This x value will be 0. I don't know what the y is. That's what we're going to find, but the x value will be 0. So what we do is we find the x value to be 0. All right, so here's my x's, and I don't see a 0, but you know what? I bet if I went back one more here, that would be 0. What would this bottom number be if I went back one more? So we go 5, 3, going down. So it'd be 1. So when x is 0, the y value is 1. That is my formula for this sequence. All right, so that's your process for finding the equation for the sequence. Let's try another one. All right, so let's follow the same thing. So this is problem number 2. Let's do 6, 11, 16, 21, and let's name the next 3 in our process here. So 26, 31, 36. And as you can see, we're just going up by 5. So to write the equation, I'm going to write x and y here. So these are my x's, y's. This is my first term, second term, third term, fourth, fifth, sixth, and that's my seventh term. So you just count up and you write y equals mx plus b. It's the old slope equation. That's how these equations work for rate of change. It's slope. So we're going to go y equals, how much am I changing by going from 6 to 11? 5. How much change by 11 to 16? 5. It's perfect. So y equals 5x plus b is the y-intercept. So we need to figure out when x is 0, what will this value be? So to find out when x is 0, I need to go back 1, which means I go down 5 from the 6. If I go down 5 from that 6, I've got 1, and this is the equation of this sequence. Let's do a check here to make sure we did it right. So here's my check. All right, and you may be asked to do a check on your homework. So y equals, let's pick the fourth term. It should be 21. If we did it right, we'll get 21. So 5 times 4 plus 1. All right, equals 20 plus 1, 21. If I put in 4 for this equation, I get 21. That's perfect. Let's check another one. All right, y equals, let's check the seventh term. 7, no, I'm sorry. Y equals 5. We're using 5. I'm going to put in a 7 for the seventh term plus 1. So when x is 7, I should get 36. And is that the case? When I put in x is 7, I do get 36. So this is the equation for that sequence. It works up here too. We didn't check because it was new. Let's just do a quick check in our head. Let's check this term right here. If I put a 5 in for x, do I get 11 out for a y? Do I put a 5 in for x? So 2 times 5 is 10, plus 1 is 11. So perfect. It does work. I could check it for any term. All right, let's do one more. I got some room down here. This will be perfect. 8, 5, 2, -1. So this one looks a little bit different. The reason why it looks different is because it's going down, not up. So when we're going down 3, down 3, down 3, down 3, down 3, down 3. So those would be the next 3 terms. And let's assign them some numbers. So this is the first term. My x's go up here, my y's go down here. Second term, third, fourth, fifth, sixth, and the seventh term. Again, you can keep going if you want. I write down y equals mx plus b. My slope is how much I'm changing. This one's a little bit trickier. I'm not changing in the upward direction. Like up here, I was going up every time. Now I'm going to go down. So to go down is just, I'm going down 3 every time, down 3. So it's minus 3x. Going down 3, down 3. This is my y-intercept. That's when x is 0. So I go back whatever it would be if I went back 1 spot from this. If I make x be 0, this would be 1 more this way. So as you can see, if I went back 1 this way, I'm going up 3 going this way, up 3 more. So I'd be at 11. Let's do a check here. Do a quick check. So let's do this check right here. So if I put in 6 for x, I should get -7 out. Y equals -3 times 6 plus 11. Y equals, that's -18 plus 11, -7. So when I put 6 in, I get -7 out. That's how that works. There's one other thing that you can do with these, and it's kind of a nice little skill to have, and there'll be a question about this. You can predict terms too. So there's like the 8th term, and you guys know the 8th term would be the 13. And the 9th term, we could keep going. Let's say what's the 20th term? Well, I don't want to work that hard and just keep subtracting 3 every time. There's an easy way to find the 20th term out here. There's a real easy way to find the 20th term. Underneath it, I got to find this number right there. So what I'm going to do is y equals -3x plus 11. And some of you may be saying it or thinking it right now. Just take this 20, put it in for the x. Y equals -3 times 20 plus 11. Y equals -60 plus 11. Y equals -49. So what is this term here? -49. So to find a specific term that you can't see or that goes forever big, I could find the 100th term just by putting 100 in here. The 100th term would be -3 times 100 plus 11. So -300 plus 11. So -289 would be the 100th term. So you can do this for any term. All you got to do is plug in the x value, the term number, and it'll find the other one for you. All right. So that is, in short, arithmetic sequences. There's one small other idea you should know, and it's going in the reverse direction. Not harder, just different. So I'm going to write for you an equation, y equals 4x minus 7. And I'm going to say list first 4 numbers. All right, list the first four numbers. So 1, 2, 3, 4, the first four numbers. So those are my x's. My y's will look like this if I put a 1 in here. Okay, I put a 1 in here. I'm going to get 4 times 1 minus 7. I'm going to write that down. 4 times 1 minus 7, that's negative 3. All right, negative 3. My second term is if I put a 2 in for x. 4 times 2, 8 minus 7 is 1. Take a 3, put it in for x. If I put 3 in for x, I get 4 times 3 is 12 minus 7 is 5. Put 4 in for x, I get 4 times 4 is 16 minus 7 is 9. And I could keep on doing this, but I said just to list the first four numbers. All right, list the first four numbers. Let's do one more of those, and we'll be done. Y equals negative 3x plus 4. And I'm going to say list numbers 3 through 7. All right, so the third term through the seventh term of the sequence. So I need the third term, the fourth term, the fifth term, the sixth term, and the seventh term. Those are my x's. Here's my y's. Take 3, plug it in here. 3 times, negative 3 times 3 is negative 9. Negative 3 times 3 is negative 9 plus 4 is negative 5. So this is negative 5. That is the third term would be negative 5. And then I take a 4 and I put it in here. Negative 3 times 4 is negative 12 plus 4 is negative 8. And as you can see, we're just going to go down 3. So we could just follow the pattern. Down 3, down 3, down 3, down 3, and down 3. Hopefully I did that right. And that's how you work with arithmetic sequences. Again, they're based off of y equals mx plus b. So when you see this, just think that's how much I'm going to go up and down. And this is my zeroth position, not my first position, my 0 position, because that's my y-intercept. Okay, good luck on your practice problems and homework, and I will talk with you soon. Have a great day.